Well, first, thanks everyone for coming at a time when everyone is crazy busy marking and getting rid of end of semester things. We have a small but all the more committed crowd to welcome Dan Angus, who is one of our key pilot project coordinators of the Visual Politics program. He coordinates the project on computational methods, and he's one of the world's leading experts dealing with that sort of topic, with the use of computers to analyze sort of large amounts of visual data. And I think it's one of the real important sort of fields, because the world around us is increasingly visual, social media is increasingly visual, and as the abstract any project outlines, most of the methods are really designed to understand verbal kind of content, not visual content. And I think if you had the tools to analyze sort of visual patterns through content and other forms of analysis over huge amounts of data, that would be really one of the big progresses in our understanding of the visual. So it's fantastic to have Dan here. And also, as I said in last week's seminar, it's wonderful to see the variety of sort of topics. Last week we dealt with witchcraft, images of witchcraft in early modern Europe, and today we have Dan talking about the use of mega computers to analyze visual data. So we can't be accused of not being interdisciplinary enough in our approach.
Fantastic.
So the project that Dan is talking about is partly, as he said, co-authors with Nick, right?
Yep.
But also the idea is sort of that Dan introduces the method of computational research for people who have an interest in it, who want to find out more, how that's done, what possibilities exist, and as always we sort of aim maybe for about half an hour, and then we could have a more dialogical kind of second part of the hour.
For sure.
And yeah, the last thing that Dan has already mentioned, he is unfortunately moving us to bigger and better places to take up an associate professorship at QUT, where they have a fantastic group that deals with digital and computational methods. And fortunately, he's not too far away, so hopefully we'll have him remain involved in the program, and we'll continue seeing him over the next few years. But thanks for joining us, and look forward to hearing what you're up to these days.
Cheers, Roland. So on that, I will be sticking around at UQ in some capacity. I'm still involved also with the ARC Centre of Excellence for Dynamics of Language, hosted here at UQ. So it looks like at this stage I'll be maintaining some kind of affiliate adjunct position here. So yeah, I'm not going to disappear completely into thin air. So to talk today's talk, I'm going to talk about some new computational methods we're developing to really look at this idea of visuality. So the overview of today, we've got a lot to get through, and hopefully some of this I can skim through. Other bits we can come back to in questions if I go a bit too fast. I want to get to the last point as quickly as possible though, but there are some interesting twists and turns along the way. So I'm going to start with the motivation for why we're doing what we're doing, then start to talk about these ideas around capturing web content, because there's some really important, interesting discussion there around some of the challenges, the ethics, and technically how we can do this. That is just interesting talking about, and it seems like this is something Nick and I are running a paper about at the moment, is just some of those politics around how we even go about gathering the content. So yeah, very much at the start of this, a head nod towards Nick Carra for his involvement and work in this. I'll defer some of this content to Nick later on as well, because he probably can talk about some of it. If you've got deep questions about the use of this at the moment, I guess Nick's the best one to answer. But also Adam Smith, who has been our research assistant on this. Adam's an IT student here at UQ and has been an absolute boon for the project. He's a very gifted student and an amazing research assistant. So a lot of credit goes towards Adam for what I'm talking about today. So our motivation. What happened for us in society in the last kind of 20 years or so is we got these things called mobile phones, right? And you've got mobile phones happening, all of a sudden every mobile phone's got a camera in the back of it. And when you put cameras in mobile phones and you connect them up to this other amazing invention of social media, you get a lot of images circulating online. And so the biggest market share of social media in terms of content is visual, pictures. Right? And also video, but mostly images. And what's interesting here is when we look in particularly scholarship, the statistics of the use of social media do not equal the volume of research that's being done. There's a huge bias towards research that's conducted on text-based social media content, a massive skew towards Twitter, And what this does for our community of scholarship is, I think it biases what we know and what we say about social media. I think we assume perhaps that Twitter has more of an impact on society than what it actually has. We downplay the impact of other social media such as Instagram and Facebook. I mean, Nick and I have even faced the challenge of, when we're writing ARC project grants, of having to describe what Instagram is, and I find that kind of perverse, the idea that you would have to describe what is actually, at least on the statistics and the research that's been done, one of the highest in terms of engagement with user platforms around. Right? So Instagram engagement, user engagement with content outstrips most of the other platforms, yet we find ourselves having to explain what Instagram is, whereas the same could not be said of Twitter, say. So basically, when I put this out, and I'm a bit of a provocateur, that I go to communication conferences, kind of swagger in and throw bombs into them and just say, hey, look, great guys, another Twitter paper. Have you thought about whether this extends to platforms other than that? And I keep asking this question. I've been asking it for the last 5 years, particularly, and the answer I get is, it's too difficult, there aren't enough methods, right? So we would love to, but we can't. We can't get the data, and we've got nothing to process it, right? So whereas a lot of people have written support tools for getting at Twitter data, so you can download Twitter data very easily, and then you can analyze it. And look, I am guilty of this because many of you who might be aware of my research is I've done a lot in text, like visual text analytics. So have used tools like Leximancer and worked with Andrew Smith in extending that tool into analyzing social media content and such. So I'm as much guilty of this as anyone, that I've supported, I guess, in a way, the proliferation of text-based methods, but no more. I guess I'm flipping around now and starting to think, all right, we need to do something serious in the visual, and that's really thanks to this project, the Visual Politics project, we've been able to pilot, I think, a fairly amazing amount of research, early research, in how we might go about doing that. So yeah, a big thanks to this project, because yeah, it has been hugely supportive for us to get this up. So let me start by going to basics. So I'm just going to have to go through a bit of like Web 101 here, so bear with me. The idea of this first part really talking about the data in the machine. As you know, the Zoolander reference will get the joke. Yeah, the data being in the machine. So when we look at web-based data, there's a bunch of common formats that data exists in on the web. The most common format is this one at the top, hypertext markup language, HTML. When you go to a website, you're looking at, and your web browser is rendering HTML. I'm going to show an example of what that looks like in a sec. So what people do when you design a web page is you'll design it in some tool, perhaps, or design it from scratch, and it will, at its base, be this kind of markup language which is interpreted and makes your website look pretty and nice. There are other formats though, right? So XML was another kind of language or data format that sat next to HTML, and it was designed for data, right? So whereas an HTML dealt with presentation, XML was designed to store as a format to store lots of data online. And JSON is another one of these. So the idea of gathering and storing data that could then be used and rendered in a web page through the HTML. There's other common formats. So CSV, if you open up things in Excel and that, you know, CSV is a common format that we use to store data in, say, tables. Raw text is another format. Microsoft Word, right? That's a data format, .doc. And JPEG, right? Image formats. So most commonly across the web, we find compressed images pervade. So yeah, so common formats we see for data. All right, so as I said, we navigate in a web browser to, say, my School of Communication and Arts, and this is what we see. Right? That's what we see in our browser. Now, depending on the browser you're using, it might look slightly different, but usually it's rendered something like this. We've all seen this. We all use the web, right? Behind it, we don't usually look at web pages like this, but that's the HTML, right? So that's what's loaded. So when I've gone on my machine and I've typed in the website for Communication and Arts, it's gone to, and it's made its way through the web to the server where this code sits. that code is sent down to my computer and my browser renders it. Because it's got the .html at the back of it, it will render it as HTML. It interprets it as a web page, and so it does that with it, right? Turns that code into that. And that's going to become important in a sec, right? So just store that thought there for a second, right? Why this is important, this simple notion of grabbing HTML data and bringing it back. I'll give an example now just to preempt this. That there is HTML from a very, very popular site, and it's Twitter, right? So that's what Twitter looks like when you look at it as HTML, not as the rendered Twitter experience you know. All right, so why is this important? Well, it's important for this question of how do we obtain web data. There are three main ways in which we do this currently in research. So one of the ways is we manually copy and paste, right? So we'll grab data online, we'll copy it, screen grab, whatever you like, right? Control-C, Control-V, and we'll do this. And we'll do this laboriously through and grab this content out that way. That's very common at the moment, particularly common with visual social media. A lot of research just does screen grabs. The other way is web scraping, right? Now, web scraping hasn't been as popular recently, but we're leading a charge to kind of make it cool again, right? And I'll explain why at the end, and you'll get this. Because what's overtaken web scraping and overtook web scraping in the last kind of decade is this idea of what we call the application programming interface, or APIs, right? I'm going to explain what an API is now. So the easiest way to understand what an API is, when I create a web platform, right? So say I create Facebook, and I want Facebook just to exist as somewhere where people type in facebook.com and they see it. I want Facebook to extend across the entirety of the web. So I want Facebook comments to be able to be embedded under news articles. I want people to be able to log in to my new widget using their Facebook ID. You know this, right? So when you go across, it says log in using Facebook, right? Right? I want the Facebook ecosystem to go far and wide. The best way I can do that is by creating an API. And so what an API is essentially, think of it like this. Facebook as a platform is like a house. And if I am designing a website and I want to embed Facebook comments on my website, I go to Facebook and I say, hey, I want to put comments on my website over here, right? Can I please do that? And they say, well, yeah, actually you can, right? Here's a key to this part of the house that contains the comments that you're allowed to embed. We're going to issue you with that key, and whenever you want to grab those comments, you come, open our web platform, grab the data you need, and put it over on your website. Right? So the idea of an API is you're issued as a user, as a developer with a key, and you can use that key to open up that platform and grab some data that website or that web platform has agreed that you can grab. Right? So basically APIs are like cross-integration. What they mean is you don't just you're not just developing websites anymore. You're developing platforms that allow certain amounts of data to go out. And I'll give you an example of what some of these are. So we usually talk about these as fields and values. So fields are properties of the data, right? So they're things like the name, time, geolocation, all these kinds of things. If you think about Twitter, it would be things like, what hashtags were used, the geolocation where the person is registered, their handle, the geolocation of the tweet itself, the time that the tweet was posted, when was that user registered on the service. All these things are accessible using an API, right? So values of these are the values for a specific social touch point. So a given tweet will have certain unique values associated with these particular fields. And you can gain access to huge amounts of these. So, there's a link down here where you can have a look at Twitter's API. Right? Now, the thing with APIs is that they're a fairly recent development on the web. There are versions of API, but they weren't really considered to be like we know the web API today back in the 70s and so. But it wasn't until about 2000 when Roy Fielding wrote a dissertation on how to do this basically across the wider web, right? How to build an API across the web. And it wasn't until 2006 when we saw this thing really accelerate. So when Twitter opened up and created an API. So up until that point, Twitter was go to the Twitter website, do your thing, and that's it. Once they figured out, well, actually, we can embed tweets in other websites, and we can make that easy for people to do that by giving them keys so they can access the data and yank it out. Right? And we saw this explosion in that. And so in the kind of early 2010s, APIs proliferated all the way across the web and are now just absolutely here to stay. APIs dominate in terms of the way that our entire web experience happens. You go to a website now or you use a mobile app, and it's likely to be using any more than 10 different APIs to stitch together your experience on that site. Anytime you see content that is being pulled, so it might be using some of Google's APIs to do things like speech-to-text recognition. It could be using something else. So it's using all these different services rather than rebuilding them and putting them all in its own one web page. All right, I'm going to pause at this point. Does that make sense, right? Yeah? All right, cool. All right, so example APIs that exist around at the moment, things like Twitter, Flickr, SoundCloud, Facebook, Fusion Tables, Tumblr, Trove, Reddit, YouTube, just a bunch of platforms that have their own APIs that make them available in different ways. Some of those APIs are more open than others, right? So some of those APIs rely on you obtaining a key, a developer key. For that, some of them require you proving that you're a developer and that you're not going to do anything bad with the data. Others, have certain limits on how many data calls you can make. So you can rate limit on an API. You can make it, so for example, Twitter places a limit on how many of these API calls you can make. So you can say, all right, I want data from Twitter based on this hashtag, and it says, okay, but we're only going to let you have 300 of those. Your key will only let you have 300 per hour. Ask for anything more than that, and we're not going to send it back to you. Right? So this whole relationship between the platform that hosts the content and has the kind of the keys, right, and gives the keys out, versus the developer who is writing the tool that needs to pull that stuff in, that's a very interesting relationship. And it leads us to what we might consider to be the political economy of the API, right? Now, when I think about APIs today, the easiest way I can understand it is like an extractive industry, right? So that there's been this kind of rush, and we've seen this in the last decade, that the idea of the value on the web today is in user data. Right? And this kind of collapse of the old notion of media industries and such pervades into this. And so this pushes across into some of the work that's happening on our kind of platforms project with Tom and others, where we're taking some of this work that we've done in visual politics and extending it to the next step. Right? The idea of looking at APIs as a tool that can be monetized, weaponized in some way, used for various political ends. So those companies, the Facebooks and others that have all of this data, have these very valuable APIs. And they've co-opted developers in the early age, right, so in those kind of 2006 onwards, right, to actually developing using the API to develop really, really cool tools that do really interesting things with their platforms. For a lot of that, they've integrated that work into their own products. So developers get access to an API, they develop up some really cool widget that does some cool stuff with, say, Twitter or Facebook data. They build that, they put it out there, it gets popular. Facebook or Twitter et al. Look at that and go, oh, that's really cool, we're going to grab that, and we're going to integrate that into our platform, we're going to take those ideas and pull that in, right? What's happened now, though, is having done all that work initially and taken all those ideas, we've had the Cambridge Analytica scandal and a lot of things, and it's kind of shut the door, right? And they've said, no, actually, we're not going to give you access to our API anymore, right? We're going to shut down, or we're going to make it really difficult for certain things to happen with that API, right? So whereas before they were very keen to allow people to use it because that developed ideas and such, now that they've obtained a position of power, it's kind of this very cynical view of many programmers and peeps in my computer science space to say, yeah, now of course they've plugged us for all the good ideas, they're shutting the door, and it's only on their terms now. Right? So yeah, it's a really interesting discussion to have around that, and we can certainly have that discussion today. All right, so for many reasons, Instagram don't have an open API anymore, so we can't actually rely on using an API to gather Instagram data. Twitter's API has been significantly altered and shut down. Same with Facebook. Right? So the big platforms no longer have a reliable API, and certainly the sense we get in the research space at the moment is they're not being good team players, right, with their APIs. They're not giving us access to the kinds of data we need reliably or in ways that facilitate our research. Twitter used to. Now it doesn't. Instagram never really did. The first Instagram API was actually written by someone outside of Instagram because they never provided an API. Someone retrofitted, built their own. Instagram took it and called it their own, and then they shut the door on it, right? So there is a fractious relationship. An easier way to do this is scraping, right, in some ways, because scraping doesn't rely necessarily on the platform saying, oh yes, you can or can't do this, right, or saying, oh, you can only take 200 of these, or you can only do this, or you can only do that. Scraping gives us more power in terms of being able to actually get at different kinds of data on our own terms. So with scraping, what happens is a computer program we write initiates a request for web content. So very much like your browser going and asking for a web page. You're typing in twitter.com and it loading up for you. We can write a program to do that, right? Using the same protocols and same kind of pipeline. Right? But instead of it rendering on a web page, what happens is that actually renders inside of a computer program. And that program then isolates specific content of interest from that request. So using all those HTML tags and things that we know, that's a picture, that's a comment, that's this, that's a heading, that's a link to some other thing. Using all those tags that are used by our browsers to render the content, we can instead grab that same content and then format it and get it ready for our own output. And then we can output that in a structured way. So we can essentially write these programs, these bots, to go, grab the content, format it, locate the image, metadata, geotags, whatever they might be, and render that and send that out. And we can do that then multiple times, because these are programs, we can rinse and repeat this many times. So like if you imagine you loading a browser, screenshotting, going to the next one, screenshot, do that process, this is automating that. But it's automating in a very structured way. Because if we can know, all right, that's the image, that's the tag associated with it, that's the author identity, that's all that, we can then feed it and structure it and put it out as a database. All right, so this is not perfect though, because what happens is the platforms know that there are people out that are doing this, right? There are many people who aren't researchers who want to do scraping as well for commercial ends and other means, right? They want to do things, they want to spam, or they want to do whatever they like. Even things like political interference, we know, this is kind of going on, like PSYOP style, grab content, and do things with it. Automate the posting of, say, fake news, whatever you like. And so for all these reasons, web services are on the lookout for this suspicious activity. And it looks suspicious, right? So when you get thousands of requests from the same IP address, the same server, all asking for similar things, it looks really sus, right? So it's really easy to spot these things sometimes because they carry with them a certain kind of fingerprint of the activity, right? It doesn't look like a human going to the website and looking for content. And so they can block requests from suspected accounts, they can slow down the actions, so they can actually go, well, don't give them that page immediately, right? Let's just slow it down a little bit. So that means that, yeah, if you increase the time it takes to serve one of those content requests by a factor of 10 or a factor of 100, we might not notice that as a user, but an automated bot, that might blow out that time, really significantly. You can require authentication to access certain content. So you can kind of put up these walls around your garden that mean that actually you need to have a legitimate handle in order to be let in even just to the basic web page. Right? So we're going to give you, when you land on the website, we're going to give you a screen, but you can't get beyond that screen unless you give us something, right? A username and a password. You can automate the creation of accounts, but then again, you get back into this kind of stuff around what looks suspect. All right? So yeah, it's this constant cat and mouse game. A lot of them also do this last thing. I like to call it the munged web page design, making the web page itself really gross in terms of its HTML. So HTML is a standard in terms of, this tag is interpreted as making the text bold, this tag makes it a heading, this tag renders it as an image, all that. But there is numerous possibilities in terms of how you arrange your web page, and it can still work any number of ways you do it. And so what they do is they munge the design to kind of throw off the scrapers. So when you get the content, it's unclear, oh, that's the username, that's the image you want, right? And they can do funny things with images as well, where they can break them down into multiple images. They still render fine, but it breaks automated methods. And Instagram does this a lot, right? They're constantly messing around with their web design, as we've found out with the design of our tool. All right, so the next part of this is, all right, let's say we write a web scraper, we can get a lot of data. How do we actually do something with that that then facilitates? Because it's one thing to say, all right, great, we can now get you away from doing the Control-C, Control-V, and we can automate the download of content. So you can get a whole ton of Instagram images using a scraper or Facebook images or whatever. Using scrapers, that's great, but now I'm left with thousands of images and I've got to manually curate them or figure out which ones are meaningful or not, right? So can we provide a first pass of labeling the image data to actually facilitate some process? All right, so this is where we move into neural networks. So this absolute genius, Frank Rosenblatt, came up with this idea back in the 50s called the perceptron. And what Rosenblatt was looking at was a way to actually kind of consider, because some predecessors before him, Pitts and McCullough, had come up with this idea of trying to replicate the human brain as a machine. And so Rosenblatt actually figured this out a little bit more mathematically of creating a neural network. And so what Rosenblatt came up with was this idea here. This is the basis of every neural network. It's the idea that, now this is where it gets a little bit on the pointy end, but I just need to make this clear. Right? There's a lot of maths here, but I'm going to break it down really, really simple for you, right? All we have are inputs, right? Now inputs can be anything from as like a binary choice, 0, 1. If you take an image, you could take every pixel in that image. You understand how an image can be comprised of pixels, right? So if I break an image up into 128 by 128 individual pixels, you could have each one of those pixels input there, right, with a value, right, based on its white to black, right? So its intensity or its hue or whatever you like. You put them in, you multiply all those numbers by a configurable, what we call a weight. So all that does is it just multiplies the input by that number that you set there. Then you add all of these numbers up. So this just squashes everything, right? It just adds all those inputs up into one number, and then it squeezes that number, because that number can get really, really big and it can get really, really small as well. But this squeezes it and says, no, it has to be between +1 and -1. That's it. That's all a neuron does. Takes a lot, any number of inputs, multiplies those inputs by a tunable number, what we call a weight, sum them, squeeze the output between 0 and 1 or -1 and 1, and then outputs that number. Right. Now these get really powerful when we daisy chain them. Right? As it turns out, one by itself, not that useful or interesting. But when you daisy chain these things in a network like this, so you have inputs coming in this case you've got 3 numbers coming in, each of those gets passed to a bunch of neurons in what we call a layer. So when you configure them in this way here, they're called a layer, and you keep doing this through these multiple layers, you end up with the ability to do really cool things at an output. So to show you an example of one of these kind of working, I'm just going to bring it across. All right, so what I've got is I've got an XY coordinate. So X1 and X2 correspond to these 2 dimensions here. I've got 4 neurons here in the first layer and 2 at the end. At the moment, all the numbers, all these weights are just randomized, and it's not really being able to do anything intelligent. But if I train this to try and differentiate between the blue and the red parts, it configures these weights. So training a neural network, what we mean by training is just adjusting the numbers on those weights. Right? So the inputs are all the same, and it just keeps rotating through those inputs. And what it's doing is changing these values in the middle here. Right? And it's making them more positive or more negative if the orange ones are more negative. And taken together, it means that when you pass in a certain value, it's predicting whether it's blue or orange. That's all it's doing on this plane. All right, so can be used in a very, very powerful way. All right, so how do we actually use these productively in a program of research like this? Well, we can train them using relationships we know about. So if we have an image and we know that image contains a person, we can say to the network, this image contains a person. And we give the network lots of images of people, and every time it guesses it right, we say, yes, fantastic, you got it right. Every time it gets it wrong, we adjust the weights a little bit to try and make it less wrong. And that's the idea of training. There's another kind of network called unsupervised. I can talk about this later, but for the moment, let's just talk about supervised learning. So this is really this question about data-driven or logic-driven. All right. You can all recognize that as the capital A, can't you? Right, so on the left there, that capital A. All right, can anyone here give me a rule for what makes a capital A a capital A?
The lines, isn't it?
Lines like that? Yeah? Do you think, like, you know, could you come up with a really concrete rule that wouldn't mean it's like confused with, say, a delta symbol or something else? Right? It's hard, right? And there's a lot of notions in life we come up with. We can recognize all of those as the letter A, right? But it's really hard to develop a rule for that, right? And this is really the distinction between bottom-up and top-down learning, right? The idea of top-down, kind of ontologically driven, you know, this is what this is and this is what it's not, and based on this very, very known rule. Versus, I have lots of examples of this thing. I can't put my finger on what makes that an A, but I know it's an A, right? And that's how neural networks work. Lots of examples, and it's all those weights and that network in the middle that figures out what it is to be, in this case, an A, or what it is to be a person in an image. All right, so many, many decades of research in this has given us these really, really powerful techniques to do this now at scale. So what we've got, thanks to social and mobile computing, we've got massive image databases of labeled data. Right? So we don't just have images, we've got images and labels. So we know that what is contained in the image. We also have very, very big complex networks with a lot of work that's been going in to figure out how to stitch all bits of the maths together. And we have really, really fast computers, GPUs. And through all of that, we have the ability to do this at a scale and at a capacity that we haven't really seen before. And so that's what this project has taken advantage of in some respect. We're using this data set called COCO, and so COCO is a huge data set that's a lot of these platforms and others have used. It's got 330,000 images inside it. Of that, there's about 1.5 million objects, distinct objects in those images. All those images are tagged for what objects are contained in there. And that's useful because we can use that to train these networks. We're using a network called MaskRCNN, and that does object detection and segmentation. So these are networks trained on that COCO data set to identify objects of interest and then kind of figure out where they are in the image. And so it's very, very good at taking an image and saying, all right, what's in this image? Well, this is a person, that's a person, that's a person, that's a person, that's a person, and all these people have about 100% confidence. The network believes 100% that is a person. There's other images, so there's a bit of a bicycle there, occluded by people and other kind of things, but it reckons it's about 77% confident that's a bicycle. This bicycle here, it's a bit more confident about, it's 97% confident that's a bicycle, even though it can only really see the front part of it in the image. So this is what makes these algorithms really powerful. They don't need the entirety of the object to classify it as that. Right? There's enough data there that even with partially obscured images, they can detect what is there. Right, so in that one there, it's been trained largely on simple objects, people, bicycles, other things. It's not obviously picking up the trees and other objects there in the background, but you can train networks to do that. It's picked up the cell phone, right? So this person's holding a mobile phone, and it's been trained and it knows how to recognize cell phones there. All right, so what we did was we stitched together the neural network with the web scraper, and now we've got a new method for visual social media analytics. So this is what the architecture looks like. So what we take is your researcher sitting down at their computer, they log on to our service, Social Reaper, which is connected to a web server. What the web server does is it then spits out jobs to virtual PCs. So it pretends, it creates users, right? Pretend users that go to Instagram and grab public data. So it can't get data that's behind private profiles, but anything that's from people who have set their profile to public is obtainable by just going to the Instagram website. All right, so it can grab those. So it can grab all those. So this just spawns off hundreds of these instances pretending to be people going to the Instagram website, grabs the images based on the query. So you can query hashtag, user, if they're public, geolocation, and grab that data down. It grabs that data, puts it out to a server, like an image classifier, so that's a database, and that also has a plug-in to what we call a GPU cluster. That does all the neural network stuff. So what you get at the end of this is a database of images and associated metadata, and you also get classified versions of those. So in terms that it's actually tried to identify the objects inside the image. All right, so now realizing time's short, I probably don't have a lot of time to go through a lot of the ways that Nick and I are looking at using this. This is an idea of how the repo looks and feels at the moment. This is subject to some change, but basically, yeah, a GUI interface where you can decide, I want to look at this, I want to look at that, so you can put in various jobs, it runs them for you, and then comes back with the data and analytics and statistics for you to analyze. So yeah, we've tried to make it as non-technical as possible. There's some technical things in there you've got to give certain information to make it work, but yeah, it gives you options about what you want to scrape. So in this case, this is Facebook page feeds and things like that. You can get this at reaper.social. It's open to anyone to grab it right now. Facebook doesn't work at the moment because of changes in their API, because we're still using the Facebook API. And Instagram, what I'm showing you today, isn't quite in there yet because we're still just figuring the last couple of things out. All right. I'm conscious I want to get to discussion. I will just mention this though. The way that Nick and I are using this at the moment is not necessarily just to harvest lots of data and look and do content analysis. We're kind of reversing the logic here a bit to kind of use this as a way to understand the manner in which the platforms are using these kinds of tools to subject users to this kind of classification or users' content. Right? So really what we're looking at is this idea of what we call algorithmic brand culture. So the idea of platforms themselves facilitating this kind of really interesting brand culture. So I'll just quickly mention this. The idea here of the interplay between the creative capacities of people, us participating in the world, and the media platforms that service. And we're specifically looking at things like music festivals and nightlife areas and nightlife culture to look at the way that algorithms are changing these spaces and impacting these spaces. So in a way, we look at things like Splendor in the Grass as these kind of hot houses or these spaces for this huge kind of technocultural creativity. So you get art installations, music performances, and brands particularly kind of going in there and doing their thing. So alcohol brands in particular are really creative. And what happens is people go to these sites, they take their photos, and they post them up on social media, right? So they take lots of photos like this, put them on Instagram. What's interesting for us is that our toolkits now can actually recognize these objects. They can recognize the text, they can recognize this as a sign, as an assemblage. They can recognize these objects and other things that are in these images. They can even be trained to recognize specific things like sky whale here or this Amish barn raising exhibit. There's certain qualities about these images which can be trained and known through the algorithm of placing people at this site. So we did a study and did a lot of this manually a while ago to actually look at about 1,644 images over a 24-hour period. Of these, the statistics of interest are these. Like half of these contained an object which was classifiable, right? Something that allowed the image to be classified and said, oh, that's at Splendor in the Grass, right? It had something that tied it to that site. And 56.3% contained a face, had a person, right? So if you had data that positioned a person at that site, or you had one of those objects that placed a person at that site, it meant that 87.5% of those images would be able to be used to tie a person to that particular cultural site at that point in time. All right. So,
sorry,
yeah.
What's an influencer? How are you?
Oh, social influencers, right? So we know that they're a specific class of user of social media right now that have huge followings, and they do things like promotional activities for brands and other things like that. So they're not just a user in the sense that I might use social media, right? They connect brands to audience.
And you normally have a specific number of, would you normally classify them according to a specific number of followers? Or
Yes, there's a number of ways. So some of them, they're just known influencers. They'll say it in their tag. Yeah, they might have a certain number of followers, and there's a certain unbalance between the number of people they follow and how many people follow them. But there is a distinction between the idea of social media influencer versus celebrity. Right. There are celebrity influencers, so celebrities who turn into influencers. But yeah, there's a whole whole discussion I can make.
Sorry.
No, that's all right, that's all right. Sorry, I just assume sometimes that people...
Splendor invite a whole crew of influencers, and their job is to kind of turn the festival into Instagram.
Is that right?
We don't
Okay.
party in-house.
Yeah, I'll finish up, yeah. So just to show you how we're using this platform now, and then I'll finish and invite questions. So we've plugged in a whole bunch of hashtags and geotags around Brisbane's nightlife, and these are some of the images we're getting out and able to classify. So we're able to do things like classify these wine glasses and these people in these images. Some things it's still getting wrong, so it thinks that it's like this decoration, this ring on this lady's finger is a cell phone, which it's not. So yeah, so obviously the network is not perfect, but yeah, you feed these images in and it can do a lot of classification, picking people out, bottles and other objects. We want to take images like this and actually try and then train the network to pick up the brands, so it actually can brand and do this brand identification.
Couldn't choose better bees, Dan?
No, look, we just fed this off the network, man. Like this is what it grabbed for us. But yeah, it gives you an idea of the way the machine kind of looks at this and takes images. So yeah, so this is me finishing off then. An open-ended methodology. So Nick and I are using this at the moment really to look and to try and critique how the kind of platform economy is evolving and how they're using user data to actually meet their ends, and there's a whole bunch of questions around them from a cultural studies perspective. But you can also just use this technique as a data harvester or image classifier. Right? So you can use this if you're doing research or want to do research on visual social media such as Instagram. You can use this to just grab lots of data, and then you can also use it to do a first pass through that to help label some of that data, perhaps, you know, figure out how many images contain people, how many images contain, you know, other objects of interest that we can train the network on. So yeah, so we think this has real power to help reveal insights into image making practice, but also the power that platforms have in processing and curating our social visual culture. So yeah, I've spoken too long. I'll invite questions and comments now though, for anyone that has that.